Our second speaker this morning is Tori Zhang. Tori is a second-year Master of Masters student in computing, and she's got previous degrees in civil engineering and structural engineering. Her project is using AR, Augmented Reality Visualisation for construction safety training. Her academic supervisor is Professor Billy Sung, also from the School of Management and Marketing in the Faculty of Business and Law, and the supervision from the HIVE has been from Michael Ovens.
Thank you, Andrew. Hello everyone, I'm Tori. My intern project is using AI visualization for construction safety training. And my supervisors are Billy Sung and Michael Ovens. So what's AR? AR is augmented reality. Imagine you are looking through your phone or wearing spatial glasses and seeing digital information layered on top of the real world around you. Just like the scenes in these two videos, that's AR in action. So in simple terms, AR enhances our real-world environment with useful digital insights. When it comes to construction safety training, AR can make training not only more engaging, but also more practical and memorable. Safety training is essential on construction sites to prevent accidents and ensure worker well-being. Nowadays, virtual reality safety training is widely used, which offers simulated environments where workers can practice scenarios without real-world risks. While AR can incorporate real-world social and environmental cues into the digital simulation, however, AR's current role in safety training is limited, mainly focusing on basic visualization tasks like displaying animation operations for text instructions, rather than full-fledged safety training programs. This suggests that developing robust AR safety training solutions has significant growth potential, offering a promising future for safety training in the construction industry. The objective of this project is to create an AR proof of concept, which is an AR application prototype for construction safety training using Unity 3D and Tiered 5. This application focused on lifting operation safety training materials provided by Construction Industry Council Hong Kong. We used Unity to build 3D training scenarios and integrate Tiered 5 to provide AR experiences on the game board where users can interact with wands. This is a process diagram. There are two stages here. The first stage is training scenario design. It started with analyzing safety training materials. This helped to create a training storyline and dialogues that reflected real-world construction safety hazards and engaged users effectively. The second stage is AR experience in development. It involved building a 3D environment, creating animations, adding audio elements, and then interacting with Tiered 5. In stage 1, we analyzed the safety training materials first. These materials are provided by Construction Industry Council Hong Kong, including VR demos from VR Cloud platform and a handbook of lifting safety. Then, based on the scenarios from training materials, a recreated training storyline and dialogues are created. This designed training scenario contains multi-role collaboration and high-risk situations. The general worker needs to decide whether to trespass into the restricted lifting zone to get his toolbox, while the signaler monitors the restricted lifting zone, which includes blind spots, and guides the crane operator on when to begin lifting an object to the designated spot. So there are 4 consequences or 4 sub-scenarios based on different action chosen. Then to make the AR training even more engaging and interactive, we added one more action choosing step for the signaler when his first choice is correct at the end of the storyline. The signaler needs to decide whether to remove the mini excavator or not. In sub-scenario 1, all chosen actions are wrong, while in sub-scenario 4.1, all actions are correct. The detailed storyline can be experienced in the demonstration session later. In stage 2, AR experience development. Development tools include AR glasses, wands, a game board of Tier 5, and a gaming laptop. The left side image shows the Tier 5 toolkit. There are glasses, wands, and a game board. About the software, it includes in Windows 10 system, Tier 5 SDK, Unity 3D, and Visual Studio Code. Here is a 3D scene that is built in Unity. We can see there is a sand ground, fences, workers, ship containers, a tall crane, a mini excavator, and other essential assets. Once the 3D assets are in place, animations can be created in Unity like this, and they can be controlled by animators and C# scripts. Here are some animations I created in the project. On the top left, you can see a tower crane lifting a concrete pipe. Moving to the bottom left, there is a mini excavator experiencing severe vibration after a collision. In the middle, we have 2 animations of a general worker entering and leaving a restricted zone. On the right side, you can see 2 animations showing a signaler moving from a height to different locations. About the audio preparing and integrating, we all know that audio is an essential part of the animations. It can complement the training scenario. In this project, there are 6 voice types. They are general worker's voice, signaler's voice, crane operator's voice, supervisor's voice, narrator's voice, and mini excavator crash sound. These audios are all controlled by C# scripts. The last step in stage 2 is interaction with Tier 5. This final step involved integrating all assets into the Tier 5, which offered unique interactive capabilities to engage trainees actively. The middle image shows how Tier 5 SDK is integrated into Unity 3D and how to separate the scenario into 2 players. We can look at the right-hand video. It shows the 3D scene in Unity being transformed into an AR scene using Tier 5. From the Tier 5 glass, we can see the AR scenario. Now let's look at the recording of sub-scenario 1, in which all chosen actions are wrong. These 2 windows are the different views of the same scenario. Let's have a look.
Roger that, starting the lift.
Lift. Good. Move the concrete pipe slowly to the designated spot. Everything looks smooth. Oh no. Someone is hurt and the equipment is destroyed. This is all my fault. I should have ensured the area was clear.
And this is a recording of sub-scenario 4.1, in which all chosen actions are correct. Let's have a look.
Where's my toolbox? I need to use it. Oh, it's over there, on that mini excavator. Wait, it's in the restricted lifting zone. I don't think I should go in there while they're working with the crane. Safety first. I'll wait until they're done. I guess I'll just borrow someone else's for now.
There's a blind spot behind those containers. I can't see everything back there. We can't start until it's clear. This is the signal. Do not start the lift yet. There's a blind area behind those containers. I need to get this cleared first.
Roger that. Not lift until you confirm.
Hey, Supervisor, we've got an issue. There's a blind spot behind those shipping containers. We need them moved before we can start the lift.
Right. I'll get someone to move them right away.
Wait a second. What's that? A mini excavator? I need to decide whether to deal with it now or move forward with the lift. The equipment's weight may compromise ground stability, causing subsidence, or may block the lifting zone, hindering operation. This needs to be cleared out immediately. Supervisor, you have a mini excavator parked in the lifting zone. It needs to be cleared before we proceed.
Understood. I'll send someone to move it right away. Hold off the lift until it's done.
This is the signal. All clear now. Confirming all blind spots are visible, and no personnel are in the restricted zone. We are good to start the lift.
Roger that. Starting the lift.
Lift. Good. Move the concrete pipe slowly to the designated spot. Everything looks smooth. Keep going. Great work. Keep lowering. Perfect. And we're done. Lifting operation complete.
Copy that. Lifting complete. Thanks for the guidance.
All right. So what you just saw are recordings of our AR training running on a PC. Because of the complexity of filming, these videos show the training scenes on a computer screen and don't fully capture the immersive AR experience. If you are interested in seeing what the AR training is really like, I invite you to join our demonstration session later. There you can experience directly how AR brings construction safety training to life in a more interactive and engaging way. Conclusion. The outcomes of this project are an effective lifting operation training scenario has been designed. An AR prototype for construction training, safety training has been successfully developed and deployed. About future work, we can expand the range of training scenarios such as confined spaces, working at heights, and heavy machinery. We also can develop AR training for more advanced AR devices. This could remove the limitations of the game board area and would enable on-site training with greater freedom of movement and more realistic interactions. This project also lays the foundation for comparing the effectiveness of traditional VR and AR construction safety training. Acknowledgements. I would like to express my sincere gratitude to all the individuals and organizations on this screen. Thank you for your support and contributions. That's all. Thank you for your listening.